the product rule. So last class we got shortcuts for taking the derivative of functions, so we don't have to do the limit definition. We don't have to do the limit as delta x approaches 0, etc. We don't have to do that anymore. We can now do the shortcut. So there are more shortcuts that we're learning today. Last class, we learned if we have, let's say, x to the third, and then we have 5 times x to the third. When we took the derivative of that, do you not wear these anymore? What did I say? Oh, it fell. Oh, okay. When you take the derivative of this, we look at just taking the derivative of x cubed, and then we multiply that by 5 afterwards. So we would do 5 times 3x squared, which is 15x squared. Questions? That's what we did last time. Questions? What is the derivative of x? What's the derivative of x? 1. What's the derivative of -3? 0. Okay, good. So now what's happening today is instead of like 5 times x cubed, we might have something like x plus 5 times x cubed. So this is no longer just a constant multiplier. We now have another function. So when we have a situation where we've got a function multiplied by a function and we want to find the derivative of that, oh my gosh. One thing I could do would be distribute this and then do what I did last time. I could do that. But then we get into sometimes you're not going to be able to do that. Okay? So if we can't simplify it and then take the derivative, then we have a product rule. And the product rule says if you're multiplying 2 functions, to take the derivative of that, we're going to take the derivative of the first function multiplied by the second function plus the first function multiplied by the derivative of the second function. So you'll take the derivative of each parts, but like you have to multiply them by the non-derivative of the other one and then add it all together. Okay? So this might be a shorter way for doing some of them as well. So this is the product rule. We're going to find the derivative, and you probably could FOIL this and do it a different way, but we're learning the product rule, so we'll do it by the product rule. Okay? So we're going to use the product rule, and this first one is going to be like f of x, and the second one will be g of x. So the derivative, we're going to take the derivative of the first function f of x. So 3x, the derivative of that is 3, minus, and then we get 4x. So that's f of x derivative. We have to multiply that by g of x. So 5 plus 4x. Then we do addition, and we take the regular f of x, 3x minus 2x squared, and then we multiply it by the derivative of g of x, which is 4. So I just wrote underneath what I was saying. And then we add those together. Okay, so I'm going to have to FOIL combine like terms. Once you combine those like terms, you've just simplified it. That's the derivative. That's the product rule. Questions about the product rule? And I just want to remind you, this is brand new. So if you have a question, probably somebody else has it too. You're just waiting for the other person to ask. Be that person. No? First, they'll have tons of questions. It is to me, but I don't know what it is to you because this is brand new to you. Okay. Let's practice another one. Now, for this one, I forget how they did it. They put this in here for a specific reason, and I can't remember what that reason is. I want to make sure I give you that reason. Anyway, so if we're going to find the derivative of this product, what do I have to change first? There's something I got to do first. Somebody know what it is? Yeah, Christopher? Yes, we need to change that 1 over x. We need to make it x to the negative first. Yeah, there's nothing special about this one. Okay. So I'll have x to the negative 1 plus 1 times x minus 1. So that is still f of x. I have not taken the derivative yet. So now we're going to do the derivative. So we'll have f prime of x. I'm going to take the derivative of the first parenthesis. So when I take the derivative of a polynomial, we do each part separately. When I take the derivative of plus 1, what does that become? 0. So I'm going to ignore that. I'm only taking the derivative of x to the negative 1. Remember, we pull the negative 1 in front, and then we subtract 1 from the exponent. So I get negative x to the negative 2. We multiply that by the second equation, or the second function, plus first function, x to the negative 1 plus 1, multiplied by the derivative of the second one, which is what is the derivative of x minus 1? 1. So negative x to the negative 2 is a negative 1 over x squared. We'll multiply that by x minus 1. Plus, I've got 1 over x plus 1, and then that's multiplied by 1. So at this point, it's suggested that we make it into something that is simplified, but potentially factored if we would need to graph this for whatever reason, or if we needed to find more information. Typically, leaving it like this is not a good way of finding information. So if you see negative exponents, I already did it, but if you see negative exponents, get rid of the negative exponent. Pull that stuff to the bottom. If we see the opportunity to add these together, let's do it. So I can find common denominator between all three terms here. I'm also going to distribute that on top. Whoops. So I'll have negative x plus 1 plus x squared over x squared. And then that simplifies a little bit further to x squared plus 1 over x squared. So you can just see the difference between from when we took the derivative, which is here, to how much nicer and simplified my answer looks here. Question? The majority of the derivative stuff, the majority of the work is just simplifying. The majority isn't actually doing the derivative step. So you'll see that as we do some more examples. The product rule can be extended to products that have more than 2 factors. So if we were doing the product rule of f of x, g of x, h of x, then we would do the derivative of f of x, we do the derivative of g of x, we do the derivative of h of x, and just multiply it by the other 2 functions each time, add them together. So it extends further. We don't have any examples of that. Now we are on quotient rule. 1/3 of the way done. So the quotient rule would be when we have 2 functions that are divided. And sometimes you can simplify it, but sometimes you can't, and we need to use the quotient rule. So the quotient rule is a lot like the product rule. It is going to say to take f prime of x, so the derivative of the top, multiply it by g of x. So we multiply by the other one, which is on the bottom. It is going to be subtraction where the product was plus. And then we do f of x multiplied by the derivative of g of x, which is the bottom. And then this one also has extra stuff. We divide by g of x squared. And I only rewrote that because I always say the f of x first. It's in a different order here. That does not matter. I'm just trying to make them both look exactly the same so I have less to memorize. So these are almost the same. The two products on top are the same. It's subtraction when we're dividing. It's addition when we're multiplying, which is what exponents do. So they kind of go together. And then this one has divided by at the end of it. So here is an example where we would use the quotient rule. So y prime is equal to, I take the derivative of the top. What is the derivative of x minus 1? 1. Multiply that by 2x plus 3. Subtract the top, x minus 1. Multiply by the derivative of 2x plus 3, which is 2. And we take that over 2x plus 3 squared. So I have taken the derivative. That part's not hard. The part that's longer usually, and it's not too bad for this one, is simplifying it. So 2x plus 3, and then I'm going to distribute a negative 2 to both of those. So I will get negative 2x plus 2. Y prime equals, what do we got? I'm going to rewrite up here. 2x plus 3 minus 2x plus 2. So we get 5 over 2x plus 3 squared. Questions? Yes, Peyton?
Do we not have to factor out the bottom of the denominator?
Okay, I think you used the wrong word. So it is factored already.
Oh,
you mean multiply out.
Yeah.
So this is why I don't. If I had to graph this for some reason, I would want the denominator factored so I could find these asymptotes. So usually if it's factored, we're going to leave it that way. Because that's how we use these functions. Good question. Okay, example 5. Find the derivative. So I can't remember if there's anything special about this one. I don't think there is. But... Nah, it's just a harder one. Okay, so we're going to take y prime, and we're going to take the derivative of the top. So on top, we've got multiple terms here. My first term, I'm going to take that 2, multiply it, and then subtract 1 off of it. So we get 4x minus 4 plus nothing. Multiply by g, 2 minus 3x. Subtract, we take the top, 2x squared minus 4x plus 3. Multiply that by the derivative of the denominator, which is negative 3. And then all over 2 minus 3x squared. So that'll be my first step. How's the speed? Am I going too fast with my first step? Okay. All right, so let's do some FOIL. I tend to make more mistakes when I talk, so I'm just going to FOIL without talking. So after I FOIL it, then I'm going to combine like terms. I'll put them in order. I think I'm pretty much done now, so. So we got product rule, we got quotient rule. With practice, do you feel like you can do this stuff? With practice. We're not about to take the quiz right this second, or the test, I should say. So now this next one, is, and by the way, all of these are worked out. If I went too fast, they're all worked out in the book, and the book is linked there. I can also put them back up at the end, and there will be a video where if you really want to fill it all in, it'll be there. This next one they have here because they want to show you another option of how you can manipulate this to make it maybe easier for yourself. I will tell you, I was practicing this question, and I practice it by not looking at how the book does it. And then I go and look at how the book does it, and I'm like, oh, okay, I see what they did there. Same thing that you should be doing when you check your answers with my answer key. You do it yourself, then you look and see if you're wrong or if you're right, but got it a different way, etc. That's what happened. So if you guys were doing this on your own, what would you do first? We just learned how to do these. What would you do first? What would you do, Megan? And you know what? That's what I did too. Because that's what I've been doing. So this question is here to show you there's other options that we could do. So I'm going to show you a different way of doing this. So you could totally do it this way and just do the derivative the way what we did the others. Okay. But there's another way that they went over in the book, and they said, how about before we take the derivative, how about if we look at the top being 3 minus 1 over x, and then we use this manipulation to multiply x over x so that we don't have a fraction inside of a fraction anymore. So now I have y equals, so I'm going to multiply that. I'm going to get 3x minus 1 over x multiplied by x plus 5. And that can just simplify a little bit further to 3x minus 1 times x squared plus 5x. So that was another way that before finding the derivative, you just change the function to make it a little bit easier for you. So I'm not going to do this one all the way out. It is done all the way on the in the book if you want to try it on your own, if you want some extra practice. But I just want to show you two different starting points. Again, when you get into higher level math, your ability of manipulating the functions is almost more important than the new stuff you're learning. Almost. Not quite, but almost. And then here's a little section that I just copied straight from the book. There's nothing to do here, but have it to refer to if you need to. Not every single quotient you see is going to need the quotient rule. For example, when you look at question A, it's divided by 6. Instead of doing the whole quotient rule where you put it over 6 squared at the end, like the whole quotient rule, you can just pull out 1/6, and it's a multiplier. It's a scalar right in front. So you can take the derivative of this, which is what they're doing, 2x plus 3, and multiply that by 1/6, completely avoiding the quotient. So if you can see that ahead of time, you're going to save yourself some time. Same thing with question B. Pull out 5/8, then take the derivative of x to the 4th, which is 4x cubed, then multiply 5/8 at the end. Did not need to use the quotient, quotient rule. Question C is a place where you might see the x down there and think, oh my gosh, I'm going to have to use the quotient rule. But they have manipulated so they didn't have to. If you look at what they did, they pulled out -3/7, and then both of these, they just divided the x out completely. And when they did that, then they've got a number multiplied by a polynomial. We can take the derivative of each part of that polynomial, and that's done. And then the last one, because the bottom had just x to the second, they pulled it up and pulled the 9/5 out. Do not need to use the quotient product there. Quotient rule. So those are just some examples where, what is it, like work smarter, not harder? Yeah, work smarter, not harder. Okay, now, this next example, I would not do the way that we're going to do it in class. Okay, we're going to use this example of what you could do. If I needed the derivative of this, I would probably FOIL the top and then do the quotient rule. Just so you know. We're doing this as an exercise to see how you can actually combine rules together. So this one, we're going to take the derivative. It is the quotient rule. But inside, we have a product. So inside of that f of x part, where g of x is on the bottom, we have a product inside of that. So what's our first step for doing the quotient rule? That's fine, I'll just write it down. So our first step is to do the derivative of the top. So now when I go to do the derivative of the top, how do I do the derivative of a product? So I'm only looking at the pink stuff right now. So I'm going to do the derivative of a product. I'm going to take the derivative of that first function, 1 minus 2x, which is negative 2. And I'm going to multiply that by 3x plus 2 plus 1 minus 2x multiplied by the derivative of 3x plus 2, 3. So that is f prime of x. That's what I just did there. So then I have to multiply that by g of x. Oops. Minus, then I take f of x, which is 1 minus 2x times 3x plus 2, and I multiply that by the derivative of the bottom, which is 5. All over 5x minus 4 squared. Okay, question about how I set it up. Okay. So now we've got a bunch of just, I mean, this is the derivative here. So we've got a bunch of simplifying. Okay. I think I did something wrong. Yes, there you go. So I just put a box around what the book has as the answer, but I'll tell you, without looking at the book, I would have done this. It doesn't get me anything. I just would have done it out of habit. Because I always it's been like drilled into my brain. Is that the right? Is that the right place? Sure. It just like if I see something, I factor it. Engraved. Is that what it is? Vector. All I remember doing in like almost all my math classes. Pretty crazy. Questions about this one? I can zoom out a little bit. The majority of what I wasn't talking through is just foiling because I tend to make more mistakes when I'm talking. So, questions? So much foiling. Foiling's easy though.
Yeah.
Okay.
It's just another one.
It is. Okay, this next one, nope, just kidding. After this. Here, this is talking about what I've already said to you a few times, is the majority of the work is coming after the differentiation. So they're showing you some examples where after differentiation, this is what we got, but then after simplifying, this is what we got. And then in the paragraph, it talks about what kind of things you definitely want to do to simplify, like get rid of negative exponents, combine like terms. What else is in here? Oh, that's all they wrote. But basically, like, keep it factored. Okay. All right. That is it for the quotient rule. We're on the third thing. Yay. See, wasn't bad. So an hour left. We are not going to spend an hour on this. Oopsies. Oh no, I lost my spot. Is it this one? Nope. Oh no, did I close it? Did I just close it? I think I just closed it. So the chain rule occurs in certain place. Looking at just the symbols might be confusing. So I'm going to explain the chain rule by looking at equations, not the symbols. So I'm just going to go past this. But the chain rule has two parts. It has to do with f of g of x. Has two parts. There is the f of x part, which is the outside. And then there's the g of x, which is the inside. And we have done f of g of x in here, in other classes, yes. We know how when you have f of g of x, you take the g of x equation, you put it inside of the f of x equation. So when we have the chain rule, we have this kind of situation. And here's two examples where we will look at these as being two separate functions. So we can see what's inside and what's outside. So if you look at question A, y equals 1 over x plus 1. And what I'm saying right now isn't necessarily the only outside inside answer. So there could be other ways to look at this, but this is one particular way that is probably the most popular way about looking at it. So for this one, the outside is going to be the 1 over something. They called it 1 over u because they're just using a u substitution for x plus 1. The inside would be the x plus 1. So those would be my two functions. My outside function is 1 over something, and then my inside function is x plus 1. And you would get 1 over x plus 1 by doing f of g of x, or f of, yes, g of x. All right, and then question B, the same way, we could look at the outside being this square root. That's the outside function. So I would be taking like the outside of something, or sorry, the square root of something. And then the inside function would be what's on the inside of the square root. When we do the chain rule, you do the derivative of the outside multiplied by the derivative of the inside. So you're going to take the derivative of the outside, then you have to multiply that by the derivative of whatever the inside is. And that's the chain rule in words. It's in symbols up higher on your paper, but question.
I think I need to see it in
Yes.
case you do it.
You just need to see it. Yeah. Agreed. So we're going to find the derivative of this using the chain rule. So in this equation, my outside is going to be to the cube power, to the third power. That's my outside. And then my inside is going to be x squared plus 1. So I'm first going to do the derivative of the outside. So we ignore the blue part. We just look at the pink. That's a power. How do we do the derivative of a power? Gavin? We bring what? Just tell me with numbers here.
It would be like you would have 3 times quantity x squared plus 1 squared.
So you pull that 3 in front, you drop the power by 1. Okay, that's the power rule. But because that only happened before when we had one term on the inside. We only had like x squared on the inside. That was it. Or did we even have x squared? Or did we just have x on the inside? Just x on the inside. Yeah. Okay. So now, because we have other stuff on the inside, now we have to multiply that by the derivative of the blue part. So now we take the derivative of x squared plus 1, which is 2x. And that is our derivative. So 6x multiplied by x squared plus 1 squared would be our derivative for this one. So they summarized that, what we just did, and we called it the general power rule. So all of the chain rules that we are doing aren't all this kind that I just did, but if they are in this same form where you're taking the power, putting it front, dropping it down, and then multiplying by the derivative of the inside, that is called the general power rule. So that is the chain rule. It just has a more specified name. So let's do it again. So using the general power rule, which is what we just did, my outside is something to the third. My inside is 3x minus 2x squared. So the derivative, I'm going to start by pulling the 3 in front, 3x minus 2x squared to the second power. Then we multiply by the derivative of the blue part, which is going to be 3 minus 4x. And then from there, just simplifying, I could distribute the 3 into the 3 minus 4x. So 9 minus 12x, and then 3x minus 2x squared squared. I would not multiply that further out. I'll just leave it. Because when we go to graph stuff, usually we want it factored. So you don't want to do all the extra work for nothing. Okay, questions? You make me nervous when you don't ask, because I can't read your eyebrows because of the mask. I made that up on the spot. You guys didn't even listen. Listen to it later. It was awesome. Okay, so rewriting before differentiating. We look at this example. We see a cube root. We're not going to differentiate with a cube root. We're going to turn that into a power. So the first thing I'm going to do is not differentiate. The first thing I'm going to do is rewrite. I'm going to have x squared plus 2 to the 2/3. And then when I see this, I say, ooh, this is the general power rule, where we've got, or AKA the chain rule. We've got this outside function to a power, and then we've got our inside function. So I'm going to differentiate. I'm going to get 2/3 times x squared plus 2 to the what? Negative 1/3 is correct. Then we multiply that by 2x. So it looks like I'll have a 4x on top, a 3 on the bottom with an x squared plus 2 to the 1/3. And then I'll just go a little bit further. 4x over 3 cube root x squared plus 2. Yeah. Questions?
We have to go to cube root on that one. Like, switch
Yeah.
it? Okay.
Well, okay, so I'm going to say you don't have to do certain things, but usually rules that we follow would be if it's given in root form, then we put it back in root form. So that's kind of like the rules I follow with math. We're going to skip these. This is just like comparing what happens if the squared is in a different place. If you would like to see these, they are in the book, all worked out. Something else that's in the book that I didn't mention is for the power rule, product rule, quotient rule, and chain rule. They have proved all of these using the limit definition of a derivative with limit approaches or delta x approaches 0. They have all of that worked out in the book. But because it being so far at the end of our year, we're not deriving it. But it is in the book if you want to refer to the limit definition of the derivative. Okay, this one is here so you could see how to manipulate this in a way that you might not think of on your own. And now that I've shown you, then you'll be like, oh, I could try that by myself in the future. Okay, but you wouldn't necessarily just think of this on your own. And if you did, that's awesome. Just want to say that's awesome. So we're going to go ahead and find the derivative of this. So you guys are going to help me somewhat. What should we do first? Ideas. What do you notice? What's the thing that stands out? Who's talking? Samato? Yes. Take it to the 1/2 instead of the square root. Okay. So we're going to have y equals x squared multiplied by 1 minus x squared to the 1/2 power. Now, that is not the derivative. That's just rewriting. Is there anything else that you guys notice here? Maybe stuff we've learned today? What, Gracie? We need to use the product. Yes, we need to use the product rule because we're, multiplying two functions. So we're going to use the product rule, which I'm rewriting it, but hopefully you can kind of remember it. So we're going to do that. That's going to give me y equals the derivative of x squared is 2x multiplied by 1 minus x squared to the 1/2 plus, then we have x squared multiplied by the derivative 1/2 parenthesis 1 minus x squared to the negative 1/2. No, I messed up. Can you tell me why I messed up? I just had to think for a second. Can anybody tell me why I messed up? I'm erasing something. I forgot what. I don't know who's talking. I can't. Oh, it's you. Multiply by negative 2x. So where is she getting multiply by negative 2x. If that wasn't in your head, let's figure out where she's getting that from. I forgot, but where'd that negative 2x come from? Not you. I know you know because you know what I did wrong. What rule, Christopher, what rule?
Derivative of what's on the inside.
The chain rule. I have to multiply by the derivative of what's on the inside. So right here, this g of x function has an outside and it has an inside. So when I did the derivative of g of x, I did the outside, then I forgot to do the inside for a half a second there. So that's the derivative of the inside. Okay. All right. Now, this question? Oh. This next step is what I was saying. You might not have seen this, might not have known where to go, but I'm going to show you a little manipulation trick that the book has for this one. So we want to combine these, but I can't really FOIL out something to a half power, and this one's to the negative a half, and they're being added. Get really messy. So what I'm going to do is I'm going to look at this as a big old binomial, plus sign in between two terms. I'm going to look at it as a binomial, and in this binomial, here's one term, and here's another term. I can factor out a greatest common factor of this binomial. And this greatest common factor is going to make my life much easier. So I'm going to factor out. Is there anything you see that is it the same in both that I could factor out? No. 2x, but.
Oh, 1 minus x squared.
Okay, so here's the thing. So there is a 1 minus x squared that's sort of in common, but I'm going to be really smart about it. And also there is an x also. But I'm going to be really smart about this 1 minus x squared. I'm going to choose something that makes the next step very easy for me. Okay, so what I am choosing to factor out is an x, so that's one of them. But then 1 minus x squared to the negative 1/2 power. Let's talk about why we're doing to the negative 1/2 power. In the second part of the binomial, the second term, this is all multiplied. I could have simplified it first somewhat more. Like I could multiply together the x squared, the half, and the negative 2x. I could have done that. Maybe I'll just throw it on there because I could have done that already. I didn't. What x squared times a half times negative 2x is negative x cubed. Okay, so what I've done here by dividing out the 1 minus x squared is what is happening right here. Like that's gone, right? Because I'm factoring it out. I'm undistributing it. Are you following me? You guys know how to factor a greatest common factor. Okay, what happens when I factor it out of here with the exponents? You subtract the exponents and you get to the first power. So my next step is going to be what I factored out, which I'll just keep in pink. Oops, that's not pink. I'll keep it in pink so you can follow. X times 1 minus x squared to the negative half. That's what I factored out. And then what I have left over in my first term will be, oh, and I factored out the x's too. 2 times 1 minus x squared to the first. Plus, in my second one, let's see, I'm taking out an x, so I have 2 of those. I'll have negative x squared, just negative x squared, right? Because everything else is gone. Am I right? I made it messy. Okay, so I factored that out. I have that in front. And then the stuff that's in black now is pretty easy to simplify. I'm going to do that off to the side for a second here. 2x minus 2x squared minus x squared. So negative 3x squared plus 2x. That's what this black part is. What, Christopher?
You factor the 2 out of the second part of that division, like the second part of binomial.
Are you talking about where there was a 1/2 and a 2? Is that what you were talking about? Yeah, they multiplied together. So they kind of disappeared on their own. All right, so now my next step, the x. Oh, I was going to do this in pink. Hold on. X over 1 minus x squared to the 1/2. Oops, squared to the 1/2. I just wrote that like that. Multiplied by negative 3x squared plus 2x. So on top, I'm going to have negative 3x to the third plus 2x squared. On the bottom, I'm going to just have the square root of 1 minus x squared. So this would be something that you might not have thought about to do before. It doesn't really come up in Algebra 2 or in the first, or in pre-calc. I guess if we're doing calculus now, so it doesn't really come up so much. Just a really simplified version, not even doing derivatives, but just like really simplified version. You know, if I had something like 4x squared minus x to the negative 2, if I had just super simplified version here, we could factor out what? X to the negative 2. I could factor out x to the second, but it's not going to make it as nice as factoring out the negative 2. So then I'm going to have x to the negative 2. I would have 4. What does this become here? X to the 4th minus, and then this becomes 1. So that would be like 4x to the 4th minus 1 over x to the 2nd. So this is just all manipulating using rules that we've learned throughout our 5 years of high school math, or whatever many it's been. 5? Nope, 4 years. All right, and then the last one, last example, differentiating a quotient raised to a power. We're going to find the derivative of this. This will be the chain rule. Why? Because there's an outside, which is that squared, and there's an entire inside, 3x minus 1 over x squared plus 3. There's an outside and an inside. So we'll go ahead and take the derivative. My outside becomes 2, 3x minus 1 over x squared plus 3 to the first power, multiplied by the derivative of the inside. So how do I do the derivative of the inside? Quotient rule. Okay, so that means we're going to take 3x minus 1 and find the derivative of that, 3, times x squared plus 3, subtract 3x minus 1 times 2x all over x squared plus 3 squared. So the quotient rule, we'll have a 2 in front. We will have on the bottom an x squared plus 3 to the third. Did you say that was easy? Oh, yeah, yeah. Just double check I didn't make any silly mistakes. minus, oh, I forgot something. I forgot about the 3x minus 1. I'm pretty sure that's how they had the answer. Yep, that's all they did for the answer. They didn't multiply anything further. So you guys have time to try the assignment.